ಎಲ್ಲ ನನ್ನ ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ನಮಸ್ಕಾರ. Today I am going to discuss on Theodolite surveying. This is session number 6. Here in this session I am going to discuss on methods of Theodolite traversing, traversing by included angle method, traversing by deflection angle method, and field checks in Theodolite traversing. These are the four concepts which I will be discussing in today's session, right? Let us go one by one about these sessions. What is meant by traversing, right? What is meant by this traversing? Traversing is one of the simplest and most popular method of establishing control networks in engineering survey. And traversing consists of series of straight lines connected successively at established points. Say if I want to find the area of the particular stations, if I want to find the area of a land, I am going to establish some control points and I am going to join all these control points by means of a straight line. This we call it as traversing, right? And in traversing we are going to measure the length of the line and also the bearing of the line. The points defining the ends of the traverse line are called as traverse stations. We call them as traverse stations or traverse points. And distance between the traverse stations are known as traverse side. And this is measured by direct measurement using tape or electronic distance measuring device, that is EDM, or by indirect method using tachometer. The distance between these two traverse station, okay, we call it as traverse side. And this traverse side can be measured using EDM or tape or tachometer. At stations where traversing side changes its direction, relative directions are measured with theodolite. See, whenever at station points the traverse sides are going to change, the direction of the traverse stations are going to change. These directions we are going to measure using theodolite, that is angle measurement. There are two types of traverse. One is called as open traverse, other one is closed traverse. And you can see this is open traverse, this is closed traverse. These are the traverse stations, and these are the lines joining the traverse stations. We call it as traverse side. And this traverse side are going to change the direction, and this direction, when it changes, this direction is measured by means of an angle. This we call it as traverse angle, right? So A, B, C, D, E, F, E, A. So this is the starting point of the traverse station, and we are going to end the traverse at the same point. The starting point and the end point are one and the same. Hence, we call this as closed traverse or closed loop traverse. See, this is the starting point of the traverse. We are doing the traversing of the particular by establishing the various traverse stations, and we are going to join all the traverse stations by means of a lines. And finally, we are ending up with the starting point. When we are going to end up with the starting point, we call this type of traverse as closed traverse. Now, coming to the open traverse. In this case, the P, Q, R, S, T, U and B. You can see here the stations P, Q, R, S, T, U, both the initial station and the terminating station are not coinciding. They are independent. The initial station and terminating station are not one and the same. It is not coinciding at the same point. So whenever you want to measure the length of the road, right? So taking the details for the road alignment, we want to take the details, okay, for canal alignments. In such case, open traverse is suitable. When closed traverse is suitable, when you want to find the area of this particular boundary, or if you want to take the details of that particular boundary, then I want to go for this type of closed traverse along the boundary, right? And sometimes if I want to take the details, very details of the particular area, then also I can go for this closed traverse, right? This is the difference between open traverse and closed traverse. So open traverse, okay, an open traverse originates from a point whose positions may be known or unknown, but terminates to the point whose positions is not known. This is open traverse whose position is not known. It is not closing. Open traverse is considered to be the least desirable type of traverse because it provides no check on the accuracy. For this reason, traverse is never deliberately left open. Open traverse is used only open projects like roads, canals, railway lines, shorelines, protection canals, boundary of river, pipelines, etc. In such cases, open traverse are suitable. This is open traverse, right? Now closed traverse. When traverse originates from a known position and also terminates to the known position. When traverse originates from a known position and also terminates to the known position is called as closed traverse. This type of closed traverse begins at a point of known control, moves through the various required unknown points and returns to the same point. See here, it returns to the same point. This type of closed traverse is considered to be the second best and used when both time for survey and limited survey controls are considered. This type of traverse permits an internal check on the accuracy of the angular measurement. You can easily check the accuracy of the work we have done. This type of closed traverse is known as geometrically and mathematically closed. This type of traverse is recommended for minor projects. So what are the uses of traverse surveying? So we know what is traverse surveying. What is the uses? To establish position of new boundary lines or to determine the position of existing boundary lines. See, if I want to establish the existing you have purchased a land. I want to fix the boundary of that particular land which you have purchased. Okay. Say bifurcation sometimes. So there is a bifurcation in the land of the land. 2 or 3 persons have purchased the land and have bifurcated them. Then you are going to establish a new boundary lines for that purpose. Okay. So this is why the traverse surveying is going to help. Sometimes to provide the control points for locating railways, highways or other construction works. And to fix the alignment of roads. Suppose if you want to construct a road, to fix the alignment of a road, in which direction the road has to be constructed, in which direction the canal has to be constructed, rivers. Okay, if I want to do the survey of existing river bodies, river bank surveying if I want to do, the boundaries if I want to fix, in such cases the traversing surveys are going to help. Sometimes to determine area encompassed within the confines of a boundary, to find the area encompassed within the confines of the boundary, and to establish control point for photogrammetric mapping. So drone surveying, to establish some control points for drone surveying, we use this traverse surveying. Traversing by direct method of angles, right, by included angles and by deflection angles. Angle between successive lines are measured by any one of the following methods. Okay, so in this method, direct method, if I take, we are going to measure the length of the line and the bearings of the line. The length and bearings of the line we are going to measure using chain or tape or EDM, electronic distance measurement, and theodolite. Sometimes we can also use total station for this particular purpose, right? The angles between the successive lines are measured. Now since we are doing for theodolite traversing, we concentrate only on theodolite now, right? So traversing can also be done using total station, as you know. So theodolite traversing we are going to concentrate. Let us concentrate only on the theodolite now. Using theodolite, how traversing has to be done, that we will discuss. So this can be done by included angle method and by deflection angle method. Traversing by included angle method, and this method is suitable for land surveying. This method is preferred for closed traverse. In this method, included angle between two successive lines are measured. And included angles are measured either by interior or exterior angle accordingly as a traverse is going to run in counterclockwise or clockwise direction. Generally, the traverse is running counterclockwise direction, right? So when great accuracy is required, angles is measured by repetition method. So we are going to measure the length of the line and also the included angle between the two successive lines. This is a traverse by included angle method, right? So what we are going to do, this is anti-clockwise direction. Okay, this is the direction of traverse, anti-clockwise traverse. The interior angles we are going to measure. These are the interior angles between two successive stations. Okay, previous class we have discussed on measurement of horizontal angle, measurement of vertical angle, measurement of horizontal angle by repetition method, reiteration method. These aspects we have discussed in previous class. Nenne class alli ella discuss madidikava. So today I will be discussing deflection angle also we have discussed. So how to measure deflection angle using theodolite. So what is deflection angle also in yesterday's class we have discussed. In today we will be discussing on theodolite traversing. Okay, what is theodolite traversing? What is meant by traversing? That we will discuss in today's class. Traversing is nothing but a survey where we will be establishing certain control points. Suppose if you have a field, okay, this is the field. Based on the purpose of survey, okay, we are going to establish certain control points. Locating these control points on the field and taking the details of the control points from the field and tracing that details in a paper, in a graph paper or a plain paper. So for tracing the details which you have collected on the field and how for tracing that, what are the details we require, what are the survey we require, that we will be studying in theodolite traversing. The type of theodolite traverse, right? What type of theodolite traverse we will be performing depends on the nature of work and the type of work we have to do. Suppose one example I will be giving. This is an area, right? This is an area. My objective of my survey is to find the area of this particular portion, and or not only finding area. I want to establish certain points, main control points in this particular area. So what I will do, I will take this as some of the main stations. A station, this is B station, this is C station, D station and E station. I am establishing 5 stations here. Suppose if you have any objects here, a building if you have here, I want to take the details of this building. For getting the details of the building, first I will be having 5 control points. From this control points, I will take the details of this particular building. See, this is the building here. This details of the building I have to take. So what I will do, I will be having this control point. From this control point, I will take the bearing and I will measure the length. Bearing and length, if I take from this particular control point, I can plot this building on a paper. I can transfer the building on a paper. Right? Suppose if you have a stream here, one stream is there through my way. The stream is there. I want to get the details of this particular stream. To get the details of this particular stream, what I will do, from this station P, I will find out the bearings and I will find the length at different locations. Okay? And from station C, I will get the details and location from this station C. C point in the distance of the bearings the company. Bearings the distance tondo, either the drainage to bit tondo, either a plot sheet of plot. And the points the stations A, B, C, D, E, these are the control points. Establishing these control points, we call it as traversing. Okay? So one way of traversing is the closed traverse. What is closed traverse? all these the control points I am going to join by means of a lines. This forms a closed traverse. So first you understand why this traversing is done. What is meant by traversing? What the traversing has to be done. Traversing ಏನಕ್ಕೆ ಮಾಡಬೇಕು ಅಂತ ಫಸ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಗೊತ್ತಾಯ್ತಾ ಕಂಟ್ರೋಲ್ ಪಾಯಿಂಟ್ಸ್ ನ ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಟ್ರಾವರ್ಸಿಂಗ್ ಮಾಡೋದು. ಇಲ್ಲಿ ಎರಡು ತರ ಟ್ರಾವರ್ಸಿಂಗ್ ಇದೆ. ಇದು ಒಂದು ಕೇಸ್ ಆಯ್ತು. ಈಗ ಏನಾಯ್ತು ಕಂಟ್ರೋಲ್ ಪಾಯಿಂಟ್ಸ್ ಈ ಏರಿಯಾದ ಕಂಟ್ರೋಲ್ ಪಾಯಿಂಟ್ಸ್ ಕಂಡಿದೆ. ಸಪೋಸ್ ನಿಮಗೆ ಒಂದು ರೈಲ್ವೆ ಲೈನ್ ರೋಡ್ ವೇ ಒಂದು ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಒಂದು ಹೊಸ ರೋಡ್ ನ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಕೆನಾಲ್ ನ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸೊ ಕೆನಾಲ್ ರೋಡ್ಸ್ ನಮಗೆ ಏರಿಯಾ ಬೇಕಾಗಲ್ಲ, ಅಲ್ಲಿ ಲೆಂತ್ ನಮ್ಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ವಾ, ಲೆಂತ್ ಇಂಪಾರ್ಟೆಂಟ್. ಅವಾಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಕಂಟ್ರೋಲ್ ಪಾಯಿಂಟ್ಸ್ ನ ಯಾವ ತರ ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತೀವಿ ನೋಡಿ, ಈ ತರ ಕಂಟ್ರೋಲ್ ಪಾಯಿಂಟ್ಸ್ ನ ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತೀವಿ. ಟೇಕ್ ದ ಓಕೆ ಲೆಂತ್ bearing and angles will be taking and bearing will be measuring, length will be measuring. So this type of the control points I am going to establish B, C, D, E, F, like this I will continue it. This we call it as open traverse. This is called closed traverse. So ಇಲ್ಲಿ control point ಇಂದ establish ಮಾಡಿದೀವಿ. A, B, C, D, E and F. Here I have established a control point in this way. Here I have established a control point in this way. In this case, we call it as a closed traverse because the starting station and terminating station both coinciding. ಎರಡು ಒಂದೇ ಆಗ್ತದೆ. The starting station, right, traverse station and terminating station ವಾಪಸ್ ಅಲ್ಲೇ ಬರ್ತಾ ಇದೆ. ಆದರೆ ಇಲ್ಲಿ the starting station and terminating station is not coinciding. It is different. Okay, the starting station and terminating station they are not coinciding. This we call it as open traverse. Open traverse. Okay, this is called closed traverse. This is the difference between closed traverse and open traverse. So where we will be using this open traverse? Where we will be using this open traverse? For taking the details along the length. Suppose if I want to do a road alignment, if I want to construction a railway, roadway, if I want to construct water supply project, if I want to construct a design a water supply project, pipelines, laying pipelines. So there the length is a criteria. I have to take the details surrounding the boundary, surrounding this alignment. Okay, for new roads we use this. For railway lines we use this. For water supply lines we use this. Canals, for aligning canals we use this. This type of traverse we call it as open traverse. Wherever you want to find the area of a particular boundary. Suppose the boundary area ಬೇಕು ನನಗೆ. So this is a boundary I have. I want to get the area of this particular boundary. What I will do? I will take the control points like this. This is A, B. This will be C, D, then E, F, G, H, I, J, K, L, M, okay, and N. See, I will establish control points along the boundary, and I will take all the details, length, angles. I am going to take, and I am going to take the bearing of the first line with respect to compass, and I am going to find out the interior angles between the various control points, various stations. Interior angles calculate ಮಾಡ್ತೀನಿ, length measure ಮಾಡ್ತೀನಿ. Length to interior angles ನ measure ಮಾಡಿ ಒಂದು ಲೈನ್ ಬೇರಿಂಗ್ ಅಂತ ತಗೊಂಡ್ರೆ ಇದನ್ನ ನಾನು ಪ್ಲಾಟ್ ಮಾಡಬಹುದು ಶೀಟ್ ಅಲ್ಲಿ. I can plot it on the sheet and I can find the area of this particular portion. ಇದರ ಏರಿಯಾನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು ಟ್ರಾವರ್ಸ್. ಅರ್ಥ ಆಯ್ತಾ? ಇಲ್ಲಿ ನಾನು ಯಾಕೆ ಓಪನ್ ಕ್ಲೋಸ್ ಟ್ರಾವರ್ಸ್ ಮಾಡಿದೆ? Why I did close traverse here? My objective is to find out the area of the boundary. Here why I did open traverse? Here I want to get the details of the either side, on either sides. Road alignment I have to do. Length is criteria here. That's why I have done the open traverse here, I have taken closed traverse here. Have you understood the applications of traversing? Right? So this is what we are going to study in this particular traverse. Which are the two types of traverse? One is closed traverse, the other one is open traverse. These are the two types of traverse. Now let us discuss how to do the closed traverse and how to do the open traverse using Theodolite. Theodolite use ಮಾಡಿ closed traverse na ಹೇಗೆ perform ಮಾಡೋದು, open traverse ಹೇಗೆ perform ಮಾಡೋದು ಅನ್ನೋದನ್ನ discuss ಮಾಡೋಣ using Theodolite. I think already you have done this using compass, right? Compass traversing you have done in your previous semester. In your second semester I think you did compass traversing, where latitude and departures you have calculated, closing error we found out, ಮಾಡಿದಿರಲ್ಲ ಇದೆಲ್ಲ problems. Same problems, same thing we will be doing using Theodolite here. There you use compass, now you will be using Theodolite. ಗೊತ್ತಾಯ್ತಾ? Theodolite ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ Theodolite ನ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಇಂಟೀರಿಯರ್ ಆಂಗಲ್ಸ್ ನ ಮೆಜರ್ ಮಾಡಲಿಕ್ಕೆ, ಇಂಟೀರಿಯರ್ ಆಂಗಲ್ಸ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಇಲ್ಲಿ Theodolite ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಲ್ಲಿ ನೀವು ಕಂಪಾಸ್ ಯೂಸ್ ಮಾಡಲ್ಲ, ಬೇರಿಂಗ್ಸ್ ತಗೊಂತಾ ಇರಲ್ಲ ಒಂದೊಂದು ಲೈನ್. ಈಚ್ ಲೈನ್ ಯು ಆರ್ ಟೇಕನ್ ಬೇರಿಂಗ್ಸ್. After taking bearings of each line, you are calculating the interior angles from the bearings. Right? From the bearings, you are calculating the interior angles. And then you are plotting the traverse on a sheet of paper. And you are finding out error. Closing error you are finding out. Using Bowditch rule and transit rule, the closing error you are corrected. I think you have done those problems, right? Similar type of problems we will be doing here also. Right? So let us see how to perform the exercise on closed traverse using transit Theodolite. Transit Theodolite na utilize ಮಾಡ್ಕೊಂಡು ಹೇಗೆ closed traverse ಮಾಡೋದು ಅನ್ನೋದನ್ನ ಕಲಿಯೋಣ ಈಗ. Okay? Now let us discuss about this closed traverse. Here there are 5 stations have been given: A, B, C, D and E. These are the 5 station points. These are the 5 control points. This is the line joining these control points. We call it as sides of the traverse. These are sides of the traverse. So how many points, how many stations do I have? 5 stations I have. A, B, C, D and E. Right? Now, I want to establish a traverse here. I want to plot this traverse on a sheet of paper. To plot this traverse on a sheet of paper, whatever the field data I have to transfer it on a sheet of paper. I want to get the details of the field. 5 points, control points have been given. These 5 control points, I want to plot it on a sheet of paper. I want to transfer it onto a sheet of paper. What is the final objective of survey? ಸರ್ವೆ ಮಾಡಿದ್ಮೇಲೆ ಅದನ್ನ ನಾವು ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಬೇಕಲ್ವಾ, ಒಂದು ಮ್ಯಾಪ್ ಅನ್ನು ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಬೇಕು. ಸೊ ಹೌ ಟು ಪ್ರಿಪೇರ್ ಅ ಮ್ಯಾಪ್ ಆಫ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ಲಾಟ್ ಆನ್ ಎ ಶೀಟ್ ಆಫ್ ಪೇಪರ್. ಟು ಪ್ರಿಪೇರ್ ದಿಸ್ ಪ್ಲಾಟ್ ಐ ವಾಂಟ್ ಟು ಟೇಕ್ ಸರ್ಟನ್ ಡೀಟೇಲ್ಸ್ ಇನ್ ದ ಫೀಲ್ಡ್. ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಕೆಲವು ಡೀಟೇಲ್ಸ್ ತಗೋಬೇಕಾಗುತ್ತೆ. ಹೇಗೆ ಆ ಡೀಟೇಲ್ಸ್ ನ ತಗೊಳ್ಳೋದು, ಟ್ರಾವರ್ಸಿಂಗ್ ಹೇಗೆ ಡೀಟೇಲ್ಸ್ ತಗೊಳ್ಳೋದು ಅದನ್ನ ಸ್ಟಡಿ ಮಾಡೋಣ. ನಿಮಗೆ 5 ಪಾಯಿಂಟ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಎ, ಬಿ, ಸಿ, ಡಿ, ಇ ಅಂತ 5 ಪಾಯಿಂಟ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಗೊತ್ತಾಯ್ತಾ? ಸೊ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀರಾ, ನೀವು ಲೆಂತ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಎ ಬಿ ಲೆಂತ್, ಬಿ ಸಿ ಲೆಂತ್, ಸಿ ಡಿ ಲೆಂತ್, ಡಿ ಇ ಲೆಂತ್ ಅಂಡ್ ಇ ಎ ಲೆಂತ್. ಹೌ ಡು ಯು ಮೆಜರ್ ದಿಸ್ ಲೆಂತ್? ಯೂಸಿಂಗ್ ಟೇಪ್. There are different methods. You can use tachometric surveying also for finding out the distance, taking steady constants, which you have in third unit. So since you are not done tachometric surveying, let us go for tape method. Using tape, you can find out this length. Length na ಕಂಡುಹಿಡಿಯಬಹುದು ನಾವು tape ಮೂಲಕ. So ಈಗ 5 ಪಾಯಿಂಟ್ಸ್ ಕೊಟ್ಬಿಟ್ಟಿರ್ತಾರೆ ನೀವು ಆಲ್ರೆಡಿ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡಿರ್ತಾರೆ. ನಿಮಗೆ ಆ ಫೀಲ್ಡ್ ಡೇಟಾನ ನೀವು ಪ್ರೊಕ್ಯೂರ್ ಮಾಡಬೇಕು, ಡೇಟಾನ ತಗೋಬೇಕು. ಹೇಗೆ ಕಲೆಕ್ಟ್ ಮಾಡೋದು ಡೇಟಾನ? ಆ 5 ಪಾಯಿಂಟ್ಸ್ ಡೇಟಾನ ಹೇಗೆ ಕಲೆಕ್ಟ್ ಮಾಡೋದು ಅದನ್ನ ಈಗ ಮಾಡೋಣ. ಫಸ್ಟ್ ಏನ್ ಮಾಡಬೇಕು, ಲೆಂತ್ ನ ಕಂಡುಹಿಡ್ಕೊಂಡು ಮಾಡಬೇಕಿರೋದೆಲ್ಲ. ಲೆಂತ್ ನ ಮೆಜರ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀರಾ, ಟೇಪ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ. ಆ ಟೇಪ್ ಯೂಸ್ ಮಾಡಿ ಎ ಬಿ ಲೆಂತ್, ಬಿ ಸಿ ಲೆಂತ್, ಸಿ ಡಿ ಲೆಂತ್, ಡಿ ಇ ಲೆಂತ್ ಅಂಡ್ ಇ ಎ ಲೆಂತ್ ಯು ಮೆಜರ್. After measuring this length, right? Now, the interior angle I have to find at A. I want to find out the interior angle EAB. Okay? So how to find out this angle EAB using Theodolite? Theodolite use ಮಾಡಿಕೊಂಡು ಹಾಗೆ angle EAB ನ ಕಂಡುಹಿಡಿಯೋದು. First ಏನು ಮಾಡ್ತೀರಾ? Set the theodolite over the station point. Do the centering. All temporary adjustments you do at station A. Which are the temporary adjustments? Centering, leveling, focusing, and removing parallax. Removing parallax and focusing. These three temporary adjustments you have to make. And then, using upper clamp screw, loose the upper clamp screw and set the angle 0 degree, 0 minutes, 0 seconds in vernier A. If vernier A is 0 degree, 0 minutes, 0 seconds, what will be vernier B? 180 degree, 0 minutes, 0 seconds. After that, after setting the angle 0 degree, 0 minutes, 0 seconds, right? Now, using lower clamp screw, tight the upper clamp screw. After setting the angle, tight the upper clamp screw, loose the lower clamp screw, and bisect station B. E station na bisect ಮಾಡಿ. Then what will be the angle here? This line will be 0 degree, 0 minutes, 0 seconds. ಈ line 0 degree, 0 minutes, 0 seconds ಇರುತ್ತೆ. So ಯಾವ ಲೈನ್ ನ AE ಲೈನ್ ನ ಮಾಡ್ಕೋಬೇಕಾಗಿದೆ. 0 degree, 0 minutes, 0 seconds ಮಾಡ್ಕೋಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ ಇದು? ನೆಕ್ಸ್ಟ್ ಅಪ್ಪರ್ ಕ್ಲಾಂಪ್ ಸ್ಕ್ರೂ ಲೂಸ್ ಮಾಡಿ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಆಂಗಲ್ ಕಂಡುಹಿಡಿಯಬೇಕಲ್ಲ, ನೆನ್ನೆ ಮಾಡಿದ್ರಲ್ಲ ನೀವು ಆಂಗಲ್ ಫೈಂಡ್. ಅದೇ ತರ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ಟೂ ಸ್ಟೇಷನ್ಸ್ ಕಂಡುಹಿಡಿದಲ್ಲ ನೆನ್ನೆ. ಇಲ್ಲಿ ರಿಪಿಟೇಷನ್ ಮೆಥಡ್ ಏನು ಬೇಡ, ಒಂದು ಆಂಗಲ್ ಕಂಡುಹಿಡಿಯಿರಿ ಸಾಕು. Now I want to find out this angle EAB. What I will do? Loose the upper clamp screw, tight the lower clamp screw. Don't loose both the screws. Loose the upper clamp screw, tight the lower clamp screw now. Then bisect station B. Bisect station B. If you bisect station B, there will be a change in the angle. Note down the reading. Right? Note down the reading in vernier A and vernier B. Take the average of these two readings. That will be the angle A. Understood? How do you find out angle B? How do you find out angle B? After finding out angle A, now shift the instrument to B station. Shift the instrument to station B. Now at station B, do all temporary adjustments. Centering, leveling, focusing. Do all temporary adjustments. After doing all temporary adjustments, now using your upper clamp screw, loose the upper clamp screw, set the angle 0 degree, 0 minutes, 0 seconds. ಮತ್ತೆ 0 degree, 0 minutes, 0 seconds set ಮಾಡಿ. ಇಲ್ಲಿ ಮಾಡಿರಲ್ಲ ಹಾಗೇನೆ same procedure you have to repeat. And then which station have to bisect from here? Bisect A. A station na bisect ಮಾಡಿ. If you bisect station A, what will be this angle here? 0 degree, 0 minutes, 0 seconds. This line will be 0 degree, 0 minutes, 0 seconds. Understood? Now I want to measure this angle B. ಏನು ಮಾಡ್ತೀರಾ angle B measure ಮಾಡೋದಕ್ಕೆ? Tight the lower clamp screw, loose the upper clamp screw. Upper clamp screw loose ಮಾಡಬೇಕು. ಯಾಕಂದ್ರೆ angle measure ಮಾಡಬೇಕಲ್ಲ ನಾವು. Angle set ಮಾಡಕ್ಕೆ, angle measure ಮಾಡಕ್ಕೆ ಯಾವ screw ಯೂಸ್ ಮಾಡಬೇಕು? Upper clamp screw ಯೂಸ್ ಮಾಡಬೇಕು. ಇಲ್ಲೂ ಸಹ upper clamp screw ನ ಲೂಸ್ ಮಾಡಿ, lower clamp screw ನ ಟೈಟ್ ಮಾಡಿ, C station ನ bisect ಮಾಡಿ. ಅವಾಗ ನಿಮಗೆ angle ಸಿಗುತ್ತೆ. Measure this angle. Right? Measure this angle in both. Note down the reading. Vernier A, vernier B. Once again. Right? Vernier A, vernier B. Note down the reading. Take the average of these two. So first you have to do it for face left, and then you have to do it for face right. First face left ಮಾಡ್ತಿದ್ದೀನಿ, ಆಮೇಲೆ face right ಮಾಡ್ತೀನಿ. So do it for this. Angle B ಗೊತ್ತಾಯ್ತಲ್ಲ measure ಮಾಡೋದಾಗೆ ಅಂತ. After measuring angle B, same procedure you have to follow. Next what you have to do? Set the instrument over station C. At station C, do all temporary adjustments. Which are the temporary adjustments? Same. Centering, leveling and focusing. Do all temporary adjustment at C. Now loose upper clamp screw. Set the angle 0 degrees, 0 minutes, 0 seconds. Bisect station B. ಈಗ station B na bisect. When you bisect station B, this line will be 0 degrees, 0 minutes, 0 seconds. Right? Now tighten the upper clamp screw, loose the lower clamp screw, bisect station B. Bisect station B, this will be 0 degrees, 0 minutes, 0 seconds. After this, what you have to do? Loose the upper clamp screw, tighten the lower clamp screw. Because I want to measure this angle C. ಗೊತ್ತಾಯ್ತಾ? Angle C measure ಮಾಡಬೇಕು. ಅದಕ್ಕೆ upper clamp screw ನ loose ಮಾಡ್ತೀನಿ, lower clamp screw ನ tight ಮಾಡ್ತೀನಿ, bisect D. Bisect station D. Then measure this angle D. Right? After measuring all the angles, take your compass, prismatic compass you take, and take the bearing of any one of this line. ಅಂದ್ರೆ ನಾವು ಬೇರಿಂಗ್ ಇಂದ ಪ್ಲಾಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಬರೀ ಆಂಗಲ್ಸ್ ಗೊತ್ತಿದ್ರೆ ನಾವು ಪ್ಲಾಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ ಶೀಟ್ ಅಲ್ಲಿ. ಅದೊಂದು ಓರಿಯಂಟೇಷನ್ ಗೊತ್ತಿರಬೇಕಲ್ವಾ? ಈ ಲೈನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ನಾರ್ತ್ ಗೆ ಯಾವ ಡೈರೆಕ್ಷನ್ ಇದೆ ಅನ್ನೋದು ಗೊತ್ತಿರಬೇಕು ನಮಗೆ. ನಾವು ಪ್ಲಾಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಶೀಟ್ ಅಲ್ಲಿ ಈ ಡೀಟೇಲ್ಸ್ ಎಲ್ಲ ಪ್ಲಾಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ನಾವು ನೆಕ್ಸ್ಟ್ ಶೀಟ್ ಅಲ್ಲಿ ಪ್ಲಾಟ್ ಮಾಡಬೇಕಾದ್ರೆ ನಮಗೆ ಇದು ಡೈರೆಕ್ಷನ್ ಗೊತ್ತಿರಬೇಕು. ನಾರ್ತ್ ಗೆ ಎಷ್ಟು ಆಂಗಲ್ ಇದೆ ಅಂತ ಗೊತ್ತಿರಬೇಕು ನಮಗೆ. Measure this bearing of this particular line AB. Note down that bearing length. So all the details you have to take here. Length of AB, then BC. You have to note down the lengths. AB length, BC length, CD length, DE length, EA length. Measure the lengths using tape. Then bearing of line AB. Bearing of line, that is 4 bearing you take. 4 bearing of line AB and back bearing of line AB. Both 4 bearing and back bearing you take. 4 bearing and back bearing. What should be the difference between 4 bearing and back bearing? It's still good. 4 bearing, back bearing difference is still good. If 4 bearing is 40 degree, what will be the back bearing? 40 plus 180, 220 degrees. 40 plus 180, 220 degrees with that. Difference between 4 bearing and back bearing should be 180 degree. ಗೊತ್ತಾಯ್ತಾ? ಮರ್ತೋಗ್ಬಿಟ್ರಾ? So 4 bearing we calculate and back bearing. Then which are the other data? Angle A, angle A, angle B, angle C, angle D and angle E. These two data are there. This is one exercise we have. Okay, this is one exercise. That is traversing by. So this is closed traverse using transit theodolite. Closed traverse using transit theodolite is one exercise you have. Gottaita point? Okay, this is about closed traverse. Now, how to do open traversing? There is one more exercise. How to get the details of open traversing? Okay. All of you have understood this?
Yes.
Oh. Okay, previous. So this is about the traverse which we have discussed using included angle method. This is a traverse by deflection angle method. Okay, this is a problem on open traverse. An open traverse is run from A to G and deflection angles are as follows. These are the station points: B station, C station, D station, E station and F station, and these are the deflection angles at different station points. At station B, deflection angle is 32 degrees 16 minutes. Station C and left, the direction is important. 18 degrees 34 to the right, 22 degrees 12 minutes to the left. At E, 42 degrees 24 minutes to the right, and at F, 52 degrees 42 minutes to the right. These are the deflection angles given, and direction of deflection angles are also mentioned. In this problem, bearing of first line is given, which is 110 degrees 6 minutes, and we have to calculate bearing of all the other lines. Bearing of first line is given, we have to find the bearing of all the other lines. Right? Now, what is the bearing of first line? 110 degrees 6 minutes is the bearing of first line. To find the bearing of the next line, BC, we will be using this. First we are going to plot this on a sheet, and after plotting this, no need of plotting this accurately to the angle, just to plot it accordingly with respect to the direction, and then let us calculate the bearing of these lines. Now, bearing of line AB already known, which is 110 degrees 6 minutes. Bearing of line BC I need. Then bearing of line BC will be equal to bearing of line AB already given, which is equal to 110 degrees 6 minutes. Then bearing of line BC is equal to, listen here, this is 110 degrees 6 minutes is the bearing of line AB minus deflection angle to the left. Since the deflection angle is to the left, I am going to subtract this deflection angle. Nodi, left the deflection angle minus what the previous bearing it is left, right? That's why I am subtracting it from the previous bearing. That is 110 degrees 6 minutes minus 32 degrees 16 minutes. Then bearing of line CD is equal to, so what is this value? 110 degrees 6 minutes minus 32 degrees 16 minutes. This value is 77 degrees 50 minutes. 77 degrees 50 minutes. Similarly, bearing of line CD is equal to 77 degrees 50 minutes. Now see the direction. What is the bearing of, what is the deflection angle at C? Is it to the right or left? Right. Since deflection angle is to the right, we are going to take plus. Plus 18 degrees 34 minutes. Therefore, what is the value of bearing of line CD? The calculated value is 96 degrees 24 minutes. 96 degrees 24 minutes. Similarly, bearing of line DE is equal to 96 degrees 24 minutes. 96 degrees 24 minutes. What is the deflection angle at E? At D? We should know the deflection angle at D. It is to the left or right? Left. So what do I have to do? Minus 22 degrees 12 minutes. Find out this value. If the deflection angle is left, you have to subtract. If deflection angle is to the right, you have to add. So 96 degrees 24 minutes minus 22 degrees 12 minutes, it is 74 degrees 12 minutes. 74 degrees 12 minutes. Similarly, bearing of line EF. Bearing of line EF is equal to 74 degrees 12 minutes bearing of previous line. Then reduce to the right one plus 42 degrees 24 minutes. And this value is 116 degrees 36 minutes. Then bearing of line FG. Bearing of line FG is equal to 160 degrees 36 minutes. That is bearing of previous line EF. Okay, bearing of previous line EF plus deflection angle at F. 52 degrees 42 minutes is the deflection angle at F. Then the value is 169 degrees 18 minutes. Is the bearing of line FG. Understood? So what we have to do? Bearing of previous line minus or plus or minus deflection angle at that particular point. Say bearing of line BC will be equal to bearing of line AB plus or minus the deflection angle. So when we will be taking plus, when deflection angle is to the right, we have to take plus, and when deflection angle is to the left, we have to take minus. Understood? So we should add the deflection angle when it is to the right. We should subtract the deflection angle when it is to the left. Like this, we are going to find the bearing of all the other lines. ಗೊತ್ತಾಯ್ತಾ ಎಲ್ಲರಿಗೂ? ಏನಪ್ಪ? ಇಲ್ಲಿ ಎರಡಕ್ಕೂ ರೈಟ್ ಬರ್ತದೆ. ರೈಟ್ ಆದ್ರೂ ಬರ್ಬೋದು, ಲೆಫ್ಟ್ ಆದ್ರೂ ಬರ್ಬೋದು. In this problem, we got right. ಇದು ಮಾಡೋಣ. ನೀವು ಎಡಿಟ್ ಮಾಡಬೇಕು ಲಾಸ್ಟ್. Now coming to field checks in Theodolite Traverse. Checks for linear measurements. To avoid errors in linear measurements, the measurement should be carried out by different parties on different dates in both the directions. This is one. So if you have done this work today, so somebody else has to do the same work the next day and they has to check the readings. Then check for latitude and departures. The sigma of latitude should be equal to 0 and sigma of departure should be equal to 0. Any closing error indicates error in linear measurements which should be balanced. Right? And field checks in Theodolite Traverse. By included angles, sum of the measured interior angles should be equal to 2n minus 4 into 90 degree, where n is number of sides of traverse. Sum of measured interior angles should be equal to 2n plus 1 into right angles. Okay. Error, if any, should not exceed least count of the theodolite into root n. The error should not be more than this. Right? Checks for angular measurements. Sum of the deflection angle should be equal to 360 degree. Sum of the deflection angle. If you add all the deflection angle, it should be equal to 360 degree. Considering right deflection angle as positive and left deflection angle as negative. These are some of the field checks in an open traverse. Now consecutive coordinates, latitude and departures. Latitude of line is the distance measured parallel to north-south line and departure of a line is measured parallel to east-west line. Latitude of a survey line may be defined as its coordinate length measured parallel to an assumed meridian. In other words, latitude is a projection of survey line on the north-south line. Latitude is a projection of survey line on the north-south line. And L is equal to, latitude L is equal to L cos theta. Then what is this L? L is the length of the line and theta is the angle. When latitude of a line is measured northward, it is termed as northing and it is positive. When latitude of a line is measured southward, that is downward, right? It is called southing and it is negative. You can see this in the diagram. This is the first quadrant, the second quadrant, third quadrant and fourth quadrant. This is a quadrantal system. If you see the quadrantal system, so if both the positive, the latitude is both positive in this case, right? In this case, when it lies between east and north, both latitude and departures are positive. So departure of any line is given by L sin theta. Consecutive coordinates, this is a so if you see, this is latitude which is parallel to north-south direction. What is departure? Which is parallel to east-west direction. We call it as departure, right? So departure of any line is given by parallel to east-west axis, and departure is given by D is equal to L sin theta. L is length of the line and theta is the angle, okay, angle between the two lines. That we call it as angle. We call it as theta. So the sign conventions, you can see the sign conventions. So OA line, it is in first quadrant, that is 0 to 90 degree. That is whole circle bearing, if you take, it is 0 to 90 degree. That is north, theta 1 degree towards east. This is in first quadrant. If it is in first quadrant, both latitude and departures are positive. If it is in first quadrant. If it is in second quadrant, that is south, theta degree towards east. That is, if the angle lies between 90 to 180, we call it as second quadrant in whole circle bearing, and if the angle is south theta 2 degree towards east, we call it is in second quadrant. In second quadrant, both latitude and departures, latitude is negative and departure is positive. And latitude is negative. And in third quadrant, if angle lies between 180 to 270, that is in whole circle bearing, if it lies between 180 to 270, and in RCB, that is a reduced bearing system, south theta 2 degree towards west. This quadrantal bearing system, south theta 3 degrees towards west, right? It lies in third quadrant. Both latitude and departures are negative. If the angle is in between 270 to 360 degree, angle of inclination is in between 270 to 360 degree, say in whole circle bearing, and north theta 4 degrees towards west. If the angle is north theta 4 degrees towards west, where latitude will be positive and departure will be negative. Latitude will be positive and departure will be negative, right? This is departure is along x-axis and latitude will be along y-axis, right? This is what we have to remember. Latitude along north-south direction and departure along east-west direction, parallel to east-west direction. See, this is the sign conventions you have to follow while calculating latitude and departure. So you can see here, this is the first quadrant, the second quadrant, third quadrant and fourth quadrant. That is theta 1, north theta 1 towards east, south theta 2 towards east, and south theta 3 towards west, and north theta 4 towards west, right? So this is how we are going to calculate the latitude and departure.